Welcome to Brain Vision.
In this problem, we're going to talk about the magnetic field generated by a moving charge. So we need to remember that if we have a charge that q, that has a charge q, moving with the velocity v, then the magnetic field generated by this charge at a distance r from the charge, so the vector that connects the charge to the point P is the vector r. So the magnetic field is equal to mu 0 divided by 4 pi r squared times q times the vector velocity times the unit vector that connects the charge to the point in question. So what we have in our problem is the setup shown here in the figure, where we have two charges. One of them has charge plus q, the other one has charge minus q. They are separated by a distance 2d. One of them is moving to the right, the other one to the left. And our goal is to calculate in question A the total magnetic field generated by the two charges at point B, point P, I'm sorry, the midpoint between the two charges. Okay. So first we're going to calculate the magnetic field generated by the positive charge. I'm going to call it B plus. Then the magnetic field generated by the negative charge, which I'm going to call B minus. And then we can sum the two magnetic fields in order to find the total magnetic field. And we have to do this in different situations. In the first situation, V prime, the speed of the negative charge, is equal to half the speed of the positive charge. Okay, so let's calculate B plus. And in order to calculate it, actually before calculating B plus, I'm going to calculate V times the unit vector in the direction of point P. Now notice that we can set up a coordinate system where the x-axis points to the right, the y-axis points upwards, and by the right-hand rule, you can see that z must be coming out of the screen. Okay, it points perpendicularly to both vectors and obeys the right-hand rule. So v for the plus charge is equal to vx cross r, and r is just a unit vector in the negative y direction. So this is minus vz. Okay. I'm also going to calculate v prime r. So v prime is minus v prime x, while the vector that connects the negative charge to point P, the unit vector is y. So this is minus v prime z as well. Okay, so b plus is equal to mu 0 q v cross r, which as I said is minus v z divided by 4 pi d squared. B minus is equal to mu 0 times minus q times minus v prime z divided by 4 pi d squared. So the total, and this is equal, of course, to mu 0 q v prime z divided by 4 pi d squared. So the total value of b, let me just get this right, is equal to mu 0 q, I'm going to write it as minus mu 0 q divided by 4 pi d squared z times v minus v prime. Okay, this is a general solution, and I'm going to apply to all the cases that the exercise gives us. In the first case, where v prime, I'm sorry, is v over 2, then v minus v prime is v over 2. So b is just minus mu 0 q v over 8 pi d squared z. Okay. In the second case, v prime is equal to v, so v minus v prime is 0, and b is just 0. And finally, in the third case, v prime is 2v, so b is minus mu 0. Notice that v minus v prime is minus v, so we have minus mu 0 q minus vz divided by 4 pi d squared. So this is mu 0 q v divided by 4 pi d squared z. Okay. Then in question B, we have to calculate what is the magnetic field, what is the force due to the magnetic field uh, on that charge Q exerts on charge Q prime, meaning that the positive charge exerts on the negative one, what's the direction of force, and also what is the direction of force that the negative charge exerts on the positive one. The exercise only asks us the direction of the force, but I'm going to calculate the direction and magnitude because we're going to need them in the next item. So remember that according to Lorentz, the magnetic force on uh, on a charged object is equal to the charge of the object times the velocity of the object cross the magnetic field. Now notice that, as I said before, the magnetic field generated by the positive charge is minus mu 0 qv z divided by 4 pi times the distance squared. The difference is that in our case now, the distance is 2d since we're interested in calculating the magnetic field at charge minus, at the negative charge. So B is minus mu 0 q v z divided by 4 pi times 2d squared. This is minus mu 0 q v divided by 16 pi d squared z. Okay. Then F on the negative charge, I'm going to call it F minus, is Q times the velocity, which, as I said before, is minus Vx cross minus mu 0 qv divided by 16 pi d squared z. So this is equal to, actually there is a prime here because this here is the velocity of the negative charge. So this is mu 0 divided by 16 pi d squared times q squared times v prime, I hope I'm not forgetting anything, times j, actually there's a minus here, because x cross j is minus y. So instead of writing the unit vector j, I'm going to write it as y. This is the force on the negative charge, and notice that it points in the negative y direction. Now, the magnetic field on the negative charge, generated by the negative charge actually, is equal to mu 0 q v prime divided by 16 pi d squared z. So F minus is q times v x. This is the speed. Actually, this is F plus. I'm sorry, the force in the positive charge. The velocity of the positive charge is Vx cross mu 0 q v prime divided by 16 pi d squared z. Okay, and this is equal to, and actually I just realized there's a minus sign lacking in the other answer. So here, let me just rectify things. In the force that acts on the negative charge, I forgot the minus sign of the negative charge, this one here. I just included. So there's an overall change of sign. So the force that is exerted on the negative charge is actually in the positive y direction. I'm sorry for that. And the force that is exerted on the positive charge is in the negative y direction. So it's minus mu 0 q squared v prime y divided by 16 pi d squared. Okay. Okay. So the force is in the negative y direction. And in question C, we have to assume that v is equal to v prime, and it's equal to 3 times 10 to the 5th meters per second. And we have to calculate the ratio between the magnetic force on a particle divided by the electric force generated by the other particle. Now notice that the magnetic force, the magnitude, is mu 0 q v prime divided by 16 pi d squared, while the electric force is q squared, and there's actually a squared here, divided by 4 pi epsilon 0 times the distance, which is 4d squared, actually 2d squared. So all this cancels out. I'm sorry. And all that is left is mu 0 epsilon 0 v squared, and here I just substituted that v prime is equal to v. Now epsilon 0, remember that c squared is 1 over epsilon 0 mu 0. So we have that this is equal to v squared over c squared, or v over c squared. So this is 3 times 10 to the 5th meters per second divided by 3 times 10 to the 8th. And this is equal to, squared, of course, 10 to the minus 6, which concludes our exercise.